A body is moving in a straight line with constant acceleration a. Its speed increases from u to v in a time of t. Which expressions can be used to determine the displacement of the body? So let us use the first equation. S is equal to ut plus half into acceleration multiplied by time square. Initial speed is given as u, time taken is t, and the acceleration is a. And let us see if we can figure out these expressions one by one. So in the option one, in the statement one, we have a ut which is present here, but we don't have the acceleration expression here. So we will go back to the basic formula for acceleration, which is the change in velocity upon time. So change in the velocity will be final velocity minus initial velocity upon time. Final velocity is v, initial velocity is given as u. So divide that by time. And let us try to put this value of acceleration in our original expression. So we will get s is equal to ut plus half. For acceleration, we'll be writing v minus u divided by t multiplied by t square. And now we can see one t can be cancelled out. So let us cancel it out. So the final expression for s will be ut plus half into v minus u multiplied by t. And now let us look at the statement 1. It is this exact statement which we have derived. Hence, the first statement is definitely correct. Next, before we move on to statement 2, it is easier to check out the statement number 3 because that is easier. The expression for displacement is v minus u divided by 2 into t. Now, this is easy to cross out because let us revise the basic concept. If an object accelerates uniformly from an initial speed u to final speed v, then the average speed is given by this formula u plus v divided by 2, which means an object which is accelerating from u to v is equivalent to an object moving at a constant speed of u plus v by 2. This means to figure out the displacement, we can either use the formula ut plus half at square or consider the situation object is moving at constant speed. So the value of acceleration will be 0. So this expression will be gone. But instead of u, we will write down the this constant speed which is u plus v by 2. So let us replace the velocity with u plus v divided by 2 multiplied by time, and the acceleration is 0 because it is traveling at a constant speed. So the final expression for s will be u plus v divided by 2 multiplied by time. And now if I go back to the statement number 3, we have a subtraction minus sign in the middle. And that is why statement 3 is definitely wrong. An object accelerating from initial speed 10 to a final speed 30 in 5 seconds, and we need to figure out the displacement. So we can use any Suvat equation. So in the diagram, it is clearly specified that initial speed is 10, final speed is 30, which means the object is clearly accelerating. Hence, the direction of acceleration is towards the right hand side. And how do we figure out the displacement? Using the equation s is equal to ut plus half at square. Now, the value of u is 10. The time value is given as 5 seconds, but we don't have the acceleration. So to find the time, we are going to use the basic expression, the change in velocity upon time. So v minus u, final speed is 30, initial speed is 10. So if we subtract them, 30 minus 10 divided by the time taken, which is 5. And if we solve this, we will get 4 meter per second square as the value of acceleration. And now let us put all the values here. So the displacement value will come out as u is 10, time is 5, acceleration we just found out as 4. And if we simplify this expression, we will get the value of displacement as 100 meters. Hence, the displacement of the object is 100 when it was accelerating from 10 to 30 in a span of 5 seconds. Now, let us consider another situation which is similar to the original one but with a slight difference. In case 1, the object was accelerating. Here in case 2, the object is decelerating. In case 1, the initial speed was 10. In the case 2, the final speed is 10. So the speeds have actually interchanged. So in the case 1, we were going from 10 to 30. In case 2, we are going from 30 to 10, which means the object is clearly decelerating and we need to figure out the displacement. So the diagram is this. Initial speed is 30, which reduces to 10. Now the object is indeed traveling towards the right, but since the object is decelerating, the direction of acceleration will be opposite to the displacement, as you can see in this figure. And we are going to start with the same approach. First, let us find the acceleration using the change in velocity upon time. So v, the final speed here is 10, initial is 30. So if we put all the values in, 10 minus 30 upon f, this will come out as negative 4. Now, since the object was decelerating, that is why the value of acceleration came out as negative. And now we can put the value of acceleration into our Suvat equation. S is equal to ut plus half at square. Initial speed in case 2 was 30. Time is the same 5 seconds. Acceleration we found out as negative 4. And if we simplify this expression, we will get 100 meters. And now if you analyze both the cases, the value of displacement is actually the same. And now we can generalize these two situations and deduce that an object which is accelerating from initial speed u to final speed v in time t is equivalent to another object which is decelerating from initial speed v to final speed u in time t. So case 1 was accelerating u to v, case 2 is decelerating v to u. And according to our analysis, these two situations are equivalent. So in case 1, it is accelerating. And how do we find the displacement? Using the Suvat equation ut plus half at square. In the case 2, where the object was decelerating, it is important for us to note that the direction of acceleration will be opposite to displacement since the object is decelerating. And how do we find the displacement in this case? We have to use the same equation ut plus half at square. But initial speed in case 2 is v. So instead of u, we are going to write v. That's the point number 1. And point number 2, in case number 1, the acceleration was a. Now, the magnitude of acceleration in case 2 will stay the same as the case 1. But in case 2, since the acceleration is towards the left-hand side, so in the equation, we will put negative a since the object is decelerating. And then our equation will look like this: Vt minus half at square, where v is the original initial speed and negative a is the acceleration. And both of these expressions are going to give us the exact same answer. So either we use ut plus half at square or Vt minus half at square. That will give us the same value of displacement. Now, coming back to the question, we had deduced that statement 1 is correct, statement 3 is wrong, and statement 2 states Vt minus half at square, which is the same as ut plus half at square, right? So, Vt minus half at square will always be equal to ut plus half at square, and that is why even statement number 2 is correct. And now, if we analyze the options, it is option C, which is the right answer to this question.